Okay, so let's start the class. It's already 10:10. We are going to start chemistry today. In chemistry, the first chapter is. Am I audible now, everyone? The first chapter in
Yes,
chemistry
yes.
is. Okay. So first chapter in chemistry we are going to start is matter. What is matter? Anyone tell me the definition of matter? Anyone? Okay. So first we'll discuss about what is chemistry. Tell me what is the chemistry? Come on, definition of chemistry at least. Who is father of modern chemistry? Everything. We'll go one by one. Basic definition, man. Who is flying officer Preeti? Come on, tell me. What is definition of chemistry or what chemistry deals with? Am I audible to you, Preeti? You people are just there in class for the sake of attendance, I think so. I don't why you are here if you are not. Okay. Anyone tell me, Devnathan?
Yes, sir.
Yes. What is chemistry?
Sir, am I audible, sir?
Yeah, of course, you are audible, man.
Chemistry is is scientific study of properties and the behaviors of matter.
Okay. So chemistry is what? It is branch of science, as Devnathan has pointed out.
Yes,
It is
sir.
branch of science which deals with composition of matter and also physical and chemical characteristics associated with different material objects. This is what chemistry. Okay. And in that matter, what matter came. So what is matter? And a French chemist known as Antonio Lavoisier, or you pronounce it however. This is the spelling of his word. He is known as the father of modern chemistry. Okay, father of modern chemistry. So here the question comes. Here next question is what is matter? Matter is what? Anything anything that occupies space and possesses mass and can be felt by any one or of our senses is known as matter. So matter is what? Anything that occupies space and has mass and can be felt by any of our senses, by skin or by eye. We can see that or hear. That is matter. See, earlier, no, Indian philosophers they classified matter into five basic elements. That is, they call it as Panch Tattva. Okay, Panch Tattva. This is the early Indian philosopher classified matter into the five things that is known as Panch Tattva. That is what? Air, water, earth, that is soil, fire. These are the early Indian philosophers have told about this. These are the five matters. And according to them, everything living or non-living things was made up of these five elements only. According to this Indian philosopher, everything which is living or non-living, these are made up of these five things only. And ancient Greek philosopher also came to conclusion with these similar classifications only for the matter. And the great Indian says that is Maharishi. One name is these are the basic facts. Okay, Maharishi, his name was Kunada. Okay. He classified, perhaps he was the first one to suggest that all forms of matter are composed of very small or tiny particles that is known as anu. And each anu may be made of still small particle that is known as Parmanu. Okay, Parmanu. And Greek thinkers, atom. In Greek, this means atom means that anything that cannot be cut or which is uncut. So this matter. Thus the matter is composed of these atoms only. So these are the definition or additional fact about this matter. You can see matter is classified into basically two different groups. Like this chart. The matter is classified into first one is based on physical classification, that is physical classification, and the next one it is chemical classification. Okay. And this physical classification is divided into three parts, that is what state, that is, someone tell me, solid, liquid and gaseous state, or liquid and gaseous. And this chemical classification is divided into, again, the two pure substances and mixture. And further, this pure substances is divided into what? Two, that is, I don't know, and this elements are, again, if you see elements are of the type that is metallic, non-metallic. Someone's mic is on, please turn it off. And the third classification is it's metalloids. And this compound is again divided into two classification, that is organic and non-organic, or inorganic, you can say inorganic compound. Okay. And the mixture is again of two types, that is spontaneous and heterogeneous. This is of two types. So this is all about the matter and classification. We'll see one by one what is solid state, liquid state, examples, gaseous states. Okay. Now there is one more that is plasma states. So that also we are going to see one by one. Got it? Shall I change slide? One when you need to speak up, then only I can go ahead. No? So here we are going to see first about that is solid state. Solid state. What is solid state? Tell me the definition of solid. Anyone?
The particles arranged in a state
Package.
so close without any vacuum.
Fixed shape, volume, fixed volume, and high density. High density, and they neither flow or not fill their container completely. Okay, because they have the fixed shape and this thing. And okay. And solid is which one which cannot be compressed. So this is also on applying compressed on applying pressure. And solids are generally that is hard and rigid. These are solid examples of solid. Come on, tell me what are the examples of solids? Metals, then woods. What else? Bricks is there. These are the examples. All the hard thing that is solid. Bricks, then copper, etc. So this is solid. Next one is liquid state. What is liquid state? Liquid states are the one which has got fixed volume, but no fixed shape. It acquires the shape of the container. Okay, wherever this is filled, that takes the shape of that container. So, but no fixed shape. That means as I've told you, this means a liquid has got a definite volume, but no definite shape. That means the liquid can take up the shape of container in which it is placed. Examples of liquids are what? Water, milk is there, alcohol, etc. These are the examples of liquid. Next is gaseous state. So gaseous state is what a gas does not have either a definite shape and it can be compressed and it can be compressed on large extent of applying pressure on it. And for examples of these gaseous states are air, oxygen, nitrogen, etc. These are the about the gases. Next, the fourth state is one more state is known as plasma states. The plasma states consist of super energetic and super excited particles. Okay, so you can write down the plasma states consist of super energetic and super excited. Okay, excited particles, and these particles are in the form of ionized. These are particles in form of ionized gases, and the matter in plasma states is a collection of three highly energetic and highly excited discharged particles. They produce like glowing. There is like fluorescent tubes are there, neon sign bulbs are there. These are the examples of this plasma. There neon sign bulbs, then fluorescent tubes. These are the example of this plasma. So they produce, glowing plasma having characteristics of color depending upon the nature of the gases. And the presence of this plasma that makes CFL bulbs are there. CFL bulbs to glow because this plasma only, plasma effect. So these are the four types of state. Now we are going to see about the property of matters. Okay. Next we are going to see about properties of matter. So here the first property of matter is what? Diffusion. Diffusion is it is process of intermixing of particle of two or more substances by their own. Okay, so diffusion is what? It is process of intermixing of particles of two or more substance by their own. Okay, and its rate is highest rate for gas and lowest for which one, solid or liquid? Diffusion. Where diffusion takes place more, that is in gas, and lowest is where? In solid. Okay, and at high temperature it result in increased rate of diffusion. Density, the next property of matter is what? Density. And density is what? Density is defined as mass per volume, mass by volume. Is gram per, and it is measurement of relative heaviness of object having constant volume and defined as mass per unit volume. Okay, and then mathematically it is represented as density equal to mass by volume. Remember this. And one additional fact about this is what at 4-degree temperature, 4-degree temperature, that density of water is highest. Remember this always. I have seen the question in NDA and CDS also this. At what degree density of water is maximum? Density is maximum, and while its specific volume is minimum. We'll study about the specific volume also later on. Specific volume is minimum. So this is about density. Next property is compression. The third property of matter is compression. Gases are more compressible because the presence of large intermolecular space, while solids are the least compressible. So compressibility is what? It is compressibility of liquid lies between of the two. So compression, it can be compression version. It is which can be compressed. So gases will be more compressible because it has large intermolecular space. Molecular space. For example, you see this is the gas like oxygen, oxygen. There are gap between this. This can be compressed, but solid it is fixed. No, it is so highly incompressible. So in the case of solid, but gases there is large intermolecular space is available. That's why gases is more compressible. The fourth property of matter is thermal expansion. Thermal expansion. So thermal expansion means what? Anything when heat is given, there is expansion due to the heat. Due to heat is known as thermal expansion, as the word suggests. And in the case of gases, it is maximum. The thermal expansion occurs in gas is maximum because again because of this intermolecular force. Okay, because of this intermolecular force is very weak in the case of gases, but in solid, the thermal expansion is minimum, maximum, and minimum. Okay, because intermolecular force of attraction is maximum in the case of solid. That's why solid is loose state of matter which is expanded due to this heat given to that. Okay. The fifth property of matter is boiling point. Boiling point is what? It is temperature at which the vapor pressure of liquid becomes equal to atmospheric pressure. So we can write the boiling point. It is the temperature at which the vapor pressure of liquid becomes equal to the atmospheric pressure. Okay, and boiling point increases in the increase of impurities. If you add any impurities, boiling point increases with increase in impurities or adding impurities. Okay, that's why if you boil water, simply to take some time, and if you add some salt or anything to water, it boils very quickly. So this is because of this presence of these impurities only in liquid. Okay, and at a high altitude, boiling point decreases. At high altitude, boiling point decreases because the atmospheric pressure is low. Boiling point decreases because atmospheric pressure is low. Pressure is low. Okay, that's why food takes more time to cook in high altitude. That's why the cooker was invented because of these things only to cook food at high altitude. Because in the cooker there is more pressure applied, so boiling point is less, and food can be cooked quickly. So if atmospheric pressure is low, boiling point will be automatically low, and food takes more time to cook at high altitude. Okay, this is the reason. The one is melting point. So melting point, it is temperature at which solids start to convert into liquid state. Liquid state. This is called melting point. Okay, so these are the six property of matter. Okay, got it. Hold on, shall we move? Next slide.
Yes, sir.
If you're listening, just switch off the mic. Okay. So this was the we have seen the matter step and classification in physical classification, that is solid, liquid, gaseous state we have seen. Then property of matter we have seen. Now we are going to see the classification based on the chemical classification. Okay, the first classification of chemical, that is into two pure substances and mixture. So first we'll see in the chemical classification. Okay, chemical classification. Here we are going to see the first one is pure substances. So pure substance is a single substances or matter which cannot be separated into other kinds of matter by any physical process is known as pure substances. And pure substances is classified that the pure substances are any substances. It is a single substances which cannot be separated into other kind of matter by any means is known as pure substance. And pure substance, as we have seen, pure substance later classified into element and compound. So there we are going to see what is element in the pure substances. The first one is element. Elements are what? Simplest form of pure substance. Elements are, it is simplest form of pure substances which can be neither broken into nor built from simpler substances by ordinary physical or chemical method. Physical or chemical method. Okay. For example, elements examples are what? Gold, silver, hydrogen, etc. So these are the example of elements. Okay. And elements we have seen the elements are divided into three types. That is, we are going to see metallic, non-metallic, and metalloids. Non-metallic and metalloids. We'll see one by one what is metals. So elements we have seen elements are further divided into three types. That is metals, non-metals, and metalloids. We'll see that one by one. Metals. What are metals? Metals are solid except for which metal is at liquid state. Anyone at room temperature?
Mercury. Sorry,
Yes.
gallium.
Mercury is at room temperature, no, or liquid. So metals are solid. Exceptional, you can write down that except mercury, which is liquid at room temperature, and metals are generally hard. Metals are hard, and they have like luster. That means shining. Metals have they have. You can write down that they have luster, high melting point MP. Okay, high melting point and boiling point, high boiling point, and also it is good conductor of what? Electricity. Good conductor of electricity. This is metal. Examples of metal, you can write down anything that is, iron, copper, gold, silver, etc. These are also metals. And the second one is non-metals. Non-metals opposite of this one, that is non-metals are element with property opposite to metals. They are found in all states of matter. They are not solid. They are not. They don't have high melting point, boiling point. They are just opposite of these metals. Okay, and they are found in all states. They do not possess luster, that is shining. Except one. Which one is which non-metal possess luster? Do not possess luster. Okay? Except iodine. This is exception. Iodine possess luster. Okay, and they are poor conductor of electricity. Examples of this are hydrogen, carbon, oxygen, trust. Okay. And third one is metalloid. Metalloids are the elements which have common property of both. It has got common properties of metals and non-metals, non-proper metals and non-metals. For example, examples of metalloids are arsenic, then bismuth, and there is also antimony, etc. These are the examples of metalloids. Next, the classification was of compound. Compound is divided into organic and non-organic. What are compounds? Compounds are pure substances that can be composed of two or more different elements. It is also pure substances that are composed of two or more different elements of two or more different elements. It is pure substance which is composed of two or more different elements are known as compounds. And it is two or more this different element is composed by fixed amount of proportion by mass. So this will be compound. For examples of this are like water. It is a fixed like H2O. And the composition like H2 is there, water H2 is there, H2, and here always there will be two hydrogen and one oxygen. So this is the mix. The proportion is fixed like 2:1. There will be always 2:1 only ratio and fixed by mass. This is how a compound is composed. Okay, sugar is there, and then salt is there. NaCl, salt. NaCl is there. One sodium and one what Cl is stand for. So these are the fixed. This is the compound. Okay. Next compound is divided to organic and inorganic. That is first one is organic. Organic compounds are the compounds obtained from living sources. Living sources are called organic compounds, and the term organic is applied to hydrocarbons and their derivatives. For examples of this is like oils is there. Okay, oils, fats, and carbohydrates, protein. These are examples of organic compounds. And inorganic compounds are the compounds obtained from non-living sources. Okay, such as non-living sources such as rocks and minerals. And examples of these non-organic substances are what? Common salt is there. Common salt, marble, washing soda. These are example of inorganic substances. Next one, the classification we have seen that is, you know, Mixture in chemicals classification. Mixture is what? A material obtained by mixing a material, any material obtained by mixing two or more substances in definite proportion is known as mixture. For example, milk is there, then petrol is there, then seawater. These are example of mixture. And mixture is further classified into homogeneous. The first one is homogeneous, and the second one is heterogeneous mixture. So homogeneous mixture is what? A mixture is said to be homogeneous if it has a uniform composition throughout. If write on, a homogeneous mixture is the mixture which has uniform composition throughout. For example, the homogeneous mixture are air, salt solution is there, salt solution. These are examples of homogeneous. The heterogeneous is just opposite of this. They do not have uniform composition. For example, of this heterogeneous mixture of what? Mixture of sulfur and sand. Sulfur and sand is there. Okay, these are the examples of heterogeneous mixture. So this is all about, we have seen about the matter, how matter is classified into different definition we have seen. Next, there are certain things which should be told to people, that is, what is law of chemical composition is that. Then before that, we need to go through the questions are from here. The separation of mixture. Okay, this is very important one. The separation of mixture. Questions are from here also. The separation, like you might have seen the sublimation. What is sublimation? Evaporation, crystallization, distillation, fractional distillation. Okay, these are the thing we need to go through this. Okay, so separation on mixers. Some method of separation of mixer are there. The first separation of mixture is sublimation. Anyone tell me what is sublimation? Sublimation is process of, come on, anyone tell me. Process of or conversion of solid into which state? Vapor, direct. Vapor state, without passing through, liquid state. And this method can be used for substances which are sublime in their separation from non-sublimate material. For examples of this are, this examples generally are sublimation or sublation. Remember this, it is process of conversion of solid into vapor state, directly from solid to vapor state. And examples of these are naphthalene. This is the naphthalene ball, you might have seen naphthalene. Then ammonium chloride is there. Ammonium chloride. Then you might have seen camphor, burning of camphor directly from solid to vapor state. This is a common one you might have seen in your home. They use it for puja and all the things. So this is camphor. This is the process of sublimation. And the process here is the one process involved in this is, the process of conversion of solid into vapor state. This process is also known as Hood frost. Okay, write down this also, the Hood frost. This is the method, or this is the process of conversion of solid into vapor state, and the process known as Hood frost. Remember this also. Okay, and then the second one is filtration. What is filtration? Filtration is the process for quick and complete removal of suspended solid particles from by liquid. Filtration, it is from liquid, any particle is there. Quick and complete separation of suspended solid particles from liquid by passing the suspension through filter paper. Okay. So this is the filtration. For examples of this is, removal of solid particles from engine oil in car engine, you see, or filtration of tea from tea leaves. That is the best example of this filtration. Okay, so removal of or filtration, right, on the filtration of tea from tea leaves. This is the process of filtration. Okay. So these are there. Then tomorrow, it's already 11 o'clock. Is out in today's class. Tomorrow we'll complete this topic and we'll start atomic structure. Okay, we'll start the class. How many are? 6 of them are here.
Yes,
So yesterday we were talking about separation of mixture. The first one we have finished, the sublimation. Then filtration also we have seen. Then there is third one is evaporation. Evaporation is what? It is process of conversion of liquid into its vapor at room temperature is called evaporation. So you can write in short, it is liquid to vapor state. Okay, this is evaporation. Remember this. The process of conversion of liquid into vapor state is called evaporation. And examples of these evaporations are like evaporation of water in summer from ponds, well, lakes, etc. So evaporation water from lakes, ponds, etc. So this is evaporation. The fourth process to separate a mixture is distillation. Okay, distillation is process of converting liquid into, again, this is at room temperature. This also write at room temperature. At room temperature, this is called evaporation. And distillation, there is a small difference between evaporation and distillation. That is, it is also process of converting liquid into vapor by heating or supplying heat. By heat, then liquid. This is called distillation. Is called distillation. Okay, the distillation involves, distillation equals to vaporization and plus condensation. Vaporization plus and examples of this are distillation process, a mixture of copper sulfate and water is separated by this. This is the example of this. Then the fifth process is, the next one is fractional distillation. Here this fractional distillation also similar to distillation, but it's not distillation. That is, except there is one exception. I mean, fractional distillation is the same as distillation, but except fractionating column is used to separate two or more volatile liquid which have different boiling point. Two or more liquids which have different boiling point and boiling point. This is what, for examples of these fractional distillations are methyl alcohol. This is separated by this methyl alcohol. Okay, this is examples of this fractional distillation. And also separation of one more example. This is separation of petrol, diesel, kerosene oil. Okay, from, these are separated from what, crude oil. So there is also this fractional distillation is used. Okay, next, the sixth one is what, chromatography. You might have heard about this. So here, the name this chromatography is derived from, Latin word which means chroma means color. Okay, chroma means color. The technique of this chromatography is based on the difference in the rate at which the components of mixer are observed in the suitable observation. And there are many types of, so chromatography is what, you can write about this chromatography. The technique of chromatography is based on difference in the rate at which components of mixture are absorbed in suitable solvent. So suitable absorbent. So this is chromatography, and there are many types of chromatography, such as, like, for example, different type of chromatography there. For example, column observation chromatography there. Then there are like thin layer chromatography, paper, gas, everything. Okay, these are the types of paper, gas chromatography. Okay, these are types of chromatography. Okay, the next one, the seventh process to separation of mixer is sedimentation. It is known as sedimentation. This method is used in one compound. In this method, the one component is liquid and the other is an insoluble solid. So here, in this process, one component is liquid and other is insoluble solid, that is heavier than liquid. Okay. For example, the separation of that. Okay, this is the process of this is called sedimentation. Separation of this. Okay, got it. One more thing is that is, eight one, that is freezing. You know what is freezing? It is conversion, the process of conversion of liquid into what? Solid by its freezing point. Okay, freezing point. Okay, this is also freezing point. You know that is. And in this chapter, one or two topics are left, that is chemical changes and physical changes. What is physical changes and chemical changes? Sometimes questions are from here. Okay, one or two questions. That is, what is physical changes? Physical changes are the changes which can be reversed back on any matter. So you can write physical changes are reversible. Okay, and in physical changes, only the physical properties of matter like color, hardness, density, etc. is what physical change. And in chemical changes, what happens? Well, in the chemical changes, the chemical composition as well as the chemical composition and chemical property of the matter changes. Properties of matter changes. Okay, and which gives result in new. Therefore, it a new substance. Therefore, it result in new substances. Substances is formed by the result of this change. Okay, so chemical changes are not reversible. It is irreversible. For example, burning of any substances, burning of anything like what burning of candle is physical change or chemical changes? Anyone? Come on, tell me. Any substance. This is chemical change. Then ripening of fruits is also chemical changes. Photosynthesis, that is also chemical change. Are the example. These are the examples of chemical changes. And here, physical changes examples are what? Like boiling of water, for example. If you boil the water, it goes into vapor state, and again, if you cool down, it will again come back to what? Liquid state. So this is physical changes. And also like vaporization is there, then melting of this is also physical changes. Then again that freezing is there, no, like freezing of water, that is also physical change. Also, it becomes solid, but again if you heat it, it will become liquid. So these are the examples of physical change. Okay, so remember always the burning of any substances is chemical changes. Okay, got it? So this was all about the first topic, that is